We are coming to another concept, which is surds under irrational numbers. If x is a positive integer and n is a positive integer, then x to the power 1 upon n is called as a surd. And so you can have square root of 6, which is 6 to the power half, is a surd, because this is x to the power 1 upon n is a surd. Or you can have cube root of 6, which will be 6 to the power 1/3. Again, it is in this format, is a surd. Or you can have 7 upon 11 and you can have square root of that. This also becomes a surd. So you have 7 upon 11 and the whole thing is to the power half. These are the surds. Now we are coming to the exercise in which we are going to see whether the given numbers are surds or no. And again, I am consulting Concise Maths by Selina Publications. Exercise 1D, and I'm coming to question number 1, where I have to state with reason whether the following are surds or not. And the first one under that is 180, the root of it. So I am going to look at the factors. 180 is 36 into 5, which gives me, from 36 I can take out the square root as 6 root 5, and you will see that 6 is a rational number and 5 is an irrational number, and so overall it is going to be a surd. This is my answer. Let us look at a few other questions. Look at your second one, which is 4th root of 27. So you know that 4th root of 27 is 3 times 3 times 3. And you know that in order to take the 4th root, I should have had one more 3 over here, and so I cannot now find a root of it, and therefore it is the 4th root of it, and that's why it is a surd. We come to the 4th one, which says cube root of 64 is going to be cube root of, now 64 is cube of 4, so that is going to be 4, which is rational, therefore not a surd. We come to the 5th one, cube root of 25 into cube root of 40 is going to be, now this is a cube root, this is a cube root, so I can take the cube root of the product of 25 and 40, which gives me cube root of 25 into 4 gives me 100, and one more 0 makes it 1000. So that's going to give me 10, and that is a rational number, so you will say therefore not a surd. So apparently you will see that it looked like a surd, because you cannot take cube root of 25, you cannot take cube root of 40, but it is a surd. Now we come to the next question, which tells about write the lowest rationalizing factor. So we have to find the rationalizing factor. Now, as the name suggests, rationalizing, so it must be an irrational number. So if I take an irrational number and if I multiply by something that will make it a rational number, then that factor becomes the rationalizing factor. So in that, the first one is 5 root 2. Now, if I take 5 root 2, I can see 5 is a rational number, so I'm safe. Root 2 is an irrational number, and so root 2 will be multiplied by another root 2. And so, in my thinking step, I will do, that is, I will say 5 root 2 multiplied by root 2, and that will give me 5 into 2, which is 10, which is a rational number. So what did I multiply it with? Of course, this I put in bracket because this is a thinking step. So I will say therefore rationalizing factor is root 2. And that is my answer. We come to the third one. It is root 5 minus 3. Now here these two are not multiplied. If they are not multiplied, then I have to look at how I can convert this minus 5. I have to convert this root 5 into 5. So what I should be doing is I should be taking root 5 minus 3 will be multiplied by root 5 plus 3. If I have two terms with minus and plus sign between them, two terms with minus and plus sign between them, it looks like a minus b into a plus b, and so I obviously will get square of a minus square of b, so it becomes root 5 whole square minus 3 square, so that gives you 5 minus 9, and that gives you minus 4. Now minus 4 is it's a rational number, and therefore what did we multiply it with? We multiplied by this, and so root 5 plus 3 is the rationalizing factor. Rationalizing factor. And that's your answer. Then another one in which you can have a little challenge is where you have 3 root 2 plus 2 root 3. Now out here again there is a plus sign, so I need to take 3 root 2 plus 2 root 3, and I need to take the rationalizing factor. If this is a plus b, I should put a minus b. So 3 root 2 minus 2 root 3, and that will give me 3 root 2 whole square minus 2 root 3 whole square, and that gives you 9 into 2 minus 4 into 3, and that gives me 18 minus 12, and that will give me 6, which which is a rational number, and therefore rationalizing factor is this one, which is 3 root 2 minus 2 root 3. And that is your answer. The other type of questions based on this are where they tell you rationalize the denominators. Now when they tell you rationalize the denominator, you have to take the fraction and look at the denominator being irrational. If it is root of 5, I need to multiply this also by root of 5. But I cannot just multiply the denominator because the whole fraction has to have the same value. So I will put like so. So I multiply and divide by root 5. So that gives me in the numerator 3 root 5 upon 5. Can you see this has become a rational number? So we have rationalized the denominator. And this is our answer. We come to the third one. Now, out here, a given fraction is 1 upon root 3 minus root 2. And so, you will again multiply and divide by the rationalizing factor of this. So, it will have to be root 3 plus and root 3 plus. So, this has to be the same numerator denominator, but here because it is like a minus b, I should put a plus b, and that will give me root 3 plus root 2, and the denominator becomes a square minus b square, so, and that gives me root 3 plus root 2 upon 1, and that is equal to root 3 plus root 2, which means the denominator has got rationalized, and that is our answer. Let us come to the next one. Out here what we will do. The numerator is root 3 plus 1 upon root 3 minus 1, and here I will only look at the denominator because my question is rationalize the denominator. And so it will be, because it is a minus b, I should put a plus b. So it will be root 3 plus 1 upon root 3 plus 1. This is minus, this should be plus. Now, in the numerator, it will be root 3 plus 1 whole square because the two brackets are same. And here it will be a square minus b square. So root 3 whole square becomes 3 minus 1. So now in the numerator, let us open the bracket. We have to expand this. So it will be root 3 square because it's a plus b whole square. What is a plus b whole square? A square plus 2ab plus b square. So it will be root 3 whole square is 3 plus 2ab means 2 into this means 2 into root 3 into 1 means 2 root 3, and plus 1 square is 1, and that will give me this, and that will give me 4 plus 2 root 3 upon 2, and then we will take out the common factor. In the numerator there is 4 here and 2 here, so it becomes 2 into bracket 2 plus root 3 upon 2, which got cancelled, and it will be 2 plus root 3. And that is your answer. Denominator is upon 1. It has been rationalized. Now, let us come to this. This, by and large, can be a little confusing, but not if you keep your mind alert. 2 root 5 plus 3 root 2 upon 2 root 5 minus 3 root 2. Multiply and divide by, there is minus sign here, so I should put plus sign here, and that should give me 2 root 5, and here and that is going to give me in the numerator 2 root 5 plus 3 root 2 whole square upon 2 root 5 whole square minus 3 root 2 whole square. Which identity have we used over here? A minus b into a plus b is equal to a square minus b square. And so we have come to the numerator here. It will be 2 root 5 whole square, go slow, plus 2 into a b, that is 2 into 2 root 5, and here 3 root 2, and plus b square, so that will be so double check a square plus 2ab plus b squared. So we are on the right track. Now the denominator 2 root 5 whole square minus 3 root 2 whole square is equal to, now the numerator 2 square is 4 into 5 plus 2 into 2 into 3, 2 2's 4 3's 12, and root 5 into root 2 plus 3 square 9 into root 2 square is 2. Here again 4 2 square and root 5 square is 5 minus 3 square 9, and here root 2 square 2, which is equal to 20 plus 12, and here under root 5 into 2 becomes 10 and plus 18, and that will give me 20 minus 18, and that will give me 20, and 18 gives me 38 plus 12 root 10 upon 2. Is there anything common here? What is common? So can we write it like so? Upon what has got cancelled, and that has given you. Is there any denominator? 1. Is 1 a rational number? Yes. Have we rationalized the denominator? Yes. And that is our answer. Now we come to the last type, in which they will ask you find the values of a and b, and they will give you an irrational number is equal to another irrational number in terms of a and b. Now when you look at a question like this, you get kind of concerned. How am I going to do this? But understand that this, when you simplify, it should become like this. Does it have a denominator? No. Does this have a denominator? Yes. And so this denominator has been rationalized because there is apparently no irrational number in the denominator. And so all we have to do is take this and rationalize it. And as we rationalize it, automatically we will have the denominator getting rationalized and it will look like so. Let's see how we do it. Let us not worry about the way it looks. Let us just keep our mind straight and start with, therefore, we will write 5 plus 3 root 2 and here 5 minus 3 root 2, and we will multiply and divide by 5 plus 3 root 2 upon 5 plus 3 root 2. Why did we take plus? Because this is minus. So a minus b into a plus b, and that will give me a plus b root 2. And so therefore I will have 5 plus 3 root 2 upon 5 square minus 3 root 2 whole square, and in the numerator there are 2 brackets, so we put square, and that's equal to a plus b root 2. Now, which rule did we use over here? A minus b into a plus b gives a squared minus b squared. Now, therefore, you will have to expand this. Which identity will you use for this? This is your a, this is your b, this is a plus b, so you will use a plus b whole square, which is a square, so we will write a square, plus 2ab, so this is 2, this is a, this is b, and plus b square, so that is, and upon it will be 5 square, which is 25, minus 3 root 2 whole square has root of 3 means 9, and root 2 square of it is 2, and that is equal to a plus b root 2, and therefore we will have 25 plus 3 to 6, 6 5 30, or you can say 5 twos or 2 5s, 10 into 3 30 root 2, and plus this will be 3 into 2, that means 6, and here it will be 25 minus 18, and that is a plus b root 2. Therefore, out here you will have 25 plus 6, which is 31, plus 30 root 2 upon 25 minus 18 is, so that will be a plus b root 2. And now you will see, therefore, as you can see, you will see there are 2 terms, but here it doesn't look like 2 terms. So what we should be doing? We should be making it into 2 terms. How do we make into 2 terms? We split it. So 31 upon 7 plus 30 root 2 upon 7, and that is equal to a plus b root 2. And so you will realize this is your a. So I'll say, therefore, a is equal to 31 upon 7, and b root 2 is equal to 30 root 2 upon 7. Root 2 got cancelled, and you will say, therefore, b is equal to 30 upon 7. So we have, therefore, a equal to 31 upon 7, B is equal to 30 upon 7.